Hello everyone, my final project is Musicalization of the Culture and Beyond. It is basically a wrestling with a musical sociological theory with the IA techniques. First, let me briefly review the problem statement. The man in the picture is called George Steiner. He proposed the concept of musicalization of culture 30 years ago, which refers to the omnipresence of music that is becoming more and more monotonous and repetitive. Based on his theory, I want to investigate three questions in my project. The first one is music becoming more and more repetitive or simpler over time? Furthermore, if so, what are the repetitiveness all about? In the end, I want to know whether the repetitiveness and the simpleness could be an informative feature to predict a song's success, along with other acoustic features. So, my project is designed to have three parts. The first part is the validation of the theory using time series analysis. I will conduct some chain tests, stationary test, and time series prediction. R and Python are the tools I use in this part. Second, I would like to look into the repetitiveness and do some descriptive analysis and text mining. I would like to figure out what is the character of the repetitive songs using visualization and topic models. In the end, I will conduct a prediction of the all-time Hot 100 singles using supervised learning algorithms. And PCA will be used for dimensionality reduction. Logistic regression, decision tree, neural networks will be used for prediction. All this machine learning works will be done on 9 platform. Okay, for the first part, I use dataset with song information and lyrics of all charted songs of Billboard year-end Hot 100 singles from 1950 to 2015. And Spotify's API was used to scrap the acoustic features of the song like the loudness and the danceability. The most relevant features of my project, the simpleness and the repetitiveness, are all calculated by myself. I assume that the simpleness somehow equals the variability. So I counted the number of difficult words for measurement. Also, I calculate for variability index. As for repetitiveness, I not only count the duplicate lines in the lyrics, I also find a workaround. I use a compression algorithm used by gzip format, that is, deflates. By comparing the bytes before and after compression, I could know how many information in the lyrics are redundant. The first question for the first part is to test the repetitive trend. The stationary test and the time series plot with smooth line shows that repetitiveness is not straight stationary, and it seems to have an increasing trend. I also had a look at its autocorrelation condition. It seems the repetitiveness feature have a strong self-correlation, which also indicates that there is a trend over time. And then I conducted 2 chain tests, and 2 chain tests here all shows that a very small p-value, which proving that the increasing trend of rap is statistically significant. Breakpoint detection shows me that around 1960, 1972, and 2004, the repetitiveness are beginning to take off rapidly. At last, I used a hot winters model for prediction. As you can see on the left of the screen, it fits very well with my historical data, and the prediction shows that in the future, the music will be more repetitive, but the exact duplicates in the lyrics will be decreased. I did similar things to simpleness list features. However, there are some tricky things here. Although they are statistical, non-stationary, and trendy, they actually show a very defined tendency. The sand slope tells me that one is decreasing and the other 3 is increasing. As for the breakpoint, the result barely comes to a consensus, but the common change point is around 1995. In the end, I changed the prediction method. I used ARIMA prediction in this time. The data fitted well after one order difference transformation, but the prediction results are contradictory again, so there are no fixed results, and maybe we need a more robust measurement. The second part of the project is to have a glimpse of the repetitiveness. First, I inspect the distribution of the repetitiveness. It shows that songs from different time like to centralize in different bins, and all songs have somehow normally distributed. The majority of the songs has repetitiveness of about 0.6 and 0.7. Among the most repetitive songs, most of them come from the 70s and 80s and 90s. And the most repetitive sound is in 1997. I put an excerpt of his lyrics on the screen, and you can see it actually repeats the chorus for 33 times. And the least repetitive songs are most from 50s and 60s, the good old days. And we are sadly to notice that no songs within the last 20 years are among the ranks of least repetitive songs. I also calculate the average repetitiveness of every artist and only plot those artists with 8 or more songs in the year-end chart. It shows that, in general, female artists' songs are more repetitive than bands, and band songs are more repetitive than males. Among the superstars, Rihanna, Lady Gaga, Britney Spears, and Maroon 5 are the artists with the highest repetitive index. Next, I did some text mining work here. I plot the frequent words in songs above and below the average. And also, I use the songs with above average value to build a topic model. Using the coherence and perplexity, I found 7 is optimal number for my topics. Actually, to be honest, I'm not good at summarizing the topics, and the table on the right of the screen just shows what I think should be the topic, and you can argue me. And the line chart shows the topic distribution over the years, and we could find some interesting facts. For example, the topic love reflection has always been a hot topic over the years, and flavors of the love used to be popular in the mid-60s and mid-80s and mid-90s, and Malaysia's Slanders gained its popularity and reigned the chart since the millennials. Okay, let's enter the last part of my project. I generated the target lab indicating whether the song entered the year-end chart or also entered the all-time chart. In addition, I performed PCA to convert the repetitiveness and the simpleness into one feature, respectively. Here is the workflow of my 9. You can see I first validated the dataset by calculating the coefficient of the variation. Then I filtered out the features according to the certain criteria. In the end, I conducted the classification using 4 algorithms. But to be honest, the result is very bad, and I think that ascribed to my very limited target samples. And I also did something, that is, I calculated the importance of each variable by filtering out specific variable at one time and calculate its error rate. By comparison, we could know that most acoustic features are good indicators for the success of a single. Simpleness and repetitiveness are also informative for prediction, and simpleness maybe weighs more than the repetitiveness. However, there are so many breakdowns when doing the prediction. For example, the logistic regression has no p-values, and so I could not determine whether I could use the coefficients for interpretation. Also, my calculation of the importance of the features that don't work with PNN neural network. Okay, so that is everything I've did for this project. Due to the time limit, I don't explain much about what I've done, and something is not clear, that is absolutely. And thanks for watching my video, and have a happy early Christmas.